Understanding how networks work is the foundation of cybersecurity. Before diving into attack techniques, penetration testing tools, or secure deployment pipelines, you need to be fluent in the basic vocabulary that describes what a network is and how data moves through it. This course introduces three essential concepts: the host, the link, and the packet. These three terms appear constantly in security documentation, tool outputs, and vulnerability reports. Mastering them now will make every one subsequent topic in this course much easier to grasp. What is a host? A host is any device connected to a network that is capable of sending or receiving data. The term comes from the idea that a device hosts services or applications that other devices can interact with. In practice, a host can be almost anything: a personal computer, a laptop, a smartphone, a web server, a printer, a router, a network switch, an Internet of Things sensor, or even a virtual machine running inside a physical server. Hosts are identified on a network using addresses. The most common addressing system today is the Internet Protocol address, which exists in two versions, version 4 and version 6. An Internet Protocol version 4 address looks like four numbers separated by dots, for example 192.168.1.10. An Internet Protocol version 6 address is longer and uses hexadecimal notation, for example 2001, 0DB8, 85A3, 00000, 0000, 0000, 8A2E, 0370, 7334. Every host connected to a network must have at least one such address so that other devices know where to send data. In a typical company network, you might have hundreds or thousands of hosts, employee workstations, database servers, application servers, email servers, printers, and network infrastructure devices. From a cybersecurity perspective, each host is a potential target. When a penetration tester runs a tool like Nmap to scan a network, they are essentially looking for all the hosts that are active and reachable, and then analyzing what services each host is running. Hosts can be grouped into two broad categories. An end host, also called an end system or endpoint, is a device that originates or terminates communication. Examples include a user's workstation, a web server, or a database server. An intermediate host is a device that forwards data from one host to another without being the final destination. Routers and switches are typical intermediate hosts. Understanding this distinction matters in security because attackers often try to compromise intermediate hosts in order to intercept or redirect traffic. What is a link? A link is the physical or logical connection between two or more hosts, or network devices, that allows data to travel between them. Think of a link as the road that connects two cities. Without the road, no vehicle can travel between them, and without a link, no data can travel between hosts. Links can be physical or wireless. A physical link is a tangible cable that carries electrical signals or light pulses. The most common type today is the Ethernet cable, also called a twisted pair cable, which connects computers to switches or routers in office and home environments. Fiber optic cables are another type of physical link, commonly used for high-speed connections between buildings, cities, or continents because they carry data as pulses of light and can cover very long distances with minimal signal loss. Wireless links do not use cables. Instead, they transmit data as radio waves through the air. Wi-Fi is the most familiar example of a wireless link in everyday life. Mobile networks such as 4G and 5G also use wireless links to connect smartphones to the internet. Wireless links are particularly interesting from a security standpoint because the signal travels through the air and can potentially be intercepted by anyone within range, which is why encryption protocols like WPA3, Wi-Fi Protected Access version 3, are essential for wireless networks. Each link has a capacity, often called bandwidth, which refers to the maximum amount of data that can pass through the link in a given period of time. Bandwidth is typically measured in bits per second. A slow link might transfer a few megabits per second, while a fast fiber optic link might transfer multiple gigabits or even terabits per second. In cybersecurity, bandwidth matters when analyzing denial of service attacks, where an attacker attempts to flood a link with so much data that legitimate traffic can no longer pass through. Links also have a concept called latency, which is the time it takes for data to travel from one end of the link to the other. A link between two computers in the same room will have very low latency, measured in microseconds. A link between a computer in Europe and a server in Asia will have much higher latency, sometimes measured in hundreds of milliseconds. Latency is important in security because some attack techniques rely on timing differences to extract information. What is a packet? A packet is the fundamental unit of data that travels across a network. When you send a file, watch a video, or load a web page, The data is not transmitted as one continuous stream in most modern networks. Instead, it is divided into small, manageable chunks called packets. Each packet travels independently across the network and may even take a different route than other packets belonging to the same communication. At the destination, the packets are reassembled in the correct order to reconstruct the original data. Every packet has two main parts, the header and the payload. The header contains control information that the network uses to deliver the packet correctly. This includes the source address, where the packet comes from, the destination address, where the packet is going, a sequence number, so the receiving host knows in what order to reassemble packets, and other fields depending on the protocol being used. The payload is the actual data being transmitted. For example, if you are loading a web page, the payload of each packet contains a portion of the HTML, images, or scripts that make up that page. To make the concept concrete, imagine you want to send a large document of 10 megabytes across the internet to a colleague. The network software on your computer will divide this document into thousands of small packets, each perhaps 1,500 bytes in size. This maximum size is called the maximum transmission unit for Ethernet networks. Each packet is labeled with your Internet Protocol address as the source and your colleague's Internet Protocol address as the destination. The packets are then sent out onto the network, where routers forward them hop by hop toward the destination. Some packets might travel through Paris, others through Frankfurt, before they all arrive at your colleague's computer and are reassembled into the original document. From a cybersecurity perspective, packets are extremely important. Tools like Wireshark allow security professionals to capture packets traveling across a network and inspect their contents. This is called packet capture or packet sniffing. By analyzing packets, a security analyst can detect suspicious traffic, identify attacks in progress, or gather evidence after a security incident. Attackers also use packet sniffing on networks they have compromised to steal credentials, session tokens, or sensitive data being transmitted without encryption. Packets can also be manipulated. An attacker with sufficient access to a network can intercept packets and modify their content before forwarding them to the destination. This is called a man-in-the-middle attack. Alternatively, an attacker can forge packets, creating packets that appear to come from a trusted source when they actually do not. This technique, called spoofing, is used in many types of attacks including certain denial-of-service attacks and session hijacking. How hosts, links, and packets work together. Now that each term has been defined, it is important to understand how they interact. A network is essentially a collection of hosts connected by links, and communication between hosts happens by sending packets over those links. Here is a simple example. Imagine a user sitting at their workstation, host A, wants to retrieve a web page from a web server, host B. The user types the address of the web page into their browser. The browser prepares a request and the operating system's network software divides this request into one or more packets. Each packet is labeled with the Internet Protocol address of host A as the source and the Internet Protocol address of host B as the destination. The packets travel over the link connecting host A to the local network switch, then over another link to the router, then across multiple links and intermediate routers across the internet, until they finally reach host B. Host B receives the packets, reassembles the request, prepares a response, the web page content, divides the response into packets, and sends them back to host A following the reverse path. Host A reassembles the packets and the browser displays the web page. In a penetration testing scenario, understanding this flow is essential. When a tester uses Nmap to discover hosts on a network, Nmap sends specially crafted packets to a range of Internet Protocol addresses and analyzes the responses. When a tester uses Wireshark to analyze traffic, they are capturing the raw packets traveling over a link. When a tester analyzes a web application, they are often looking at the packets exchanged between a browser, a host, and a web server, another host, to identify vulnerabilities in the data being transmitted. Key points to remember. A host is any device connected to a network capable of sending or receiving data. Hosts are identified by Internet Protocol addresses. A link is the physical or logical connection between hosts over which data travels. Links can be wired, Ethernet, fiber optic, or wireless, Wi-Fi, mobile networks. Links have characteristics like bandwidth and latency. A packet is the basic unit of data transmitted across a network. Each packet has a header, containing addressing and control information, and a payload, containing the actual data. Large data is divided into multiple packets which are reassembled at the destination. In cybersecurity, hosts are targets and attackers, links are the medium through which attacks travel and can be intercepted, and packets are the data units that can be captured, analyzed, forged, or modified by both defenders and attackers. These three concepts form the absolute foundation of network understanding. Every more advanced topic in networking and cybersecurity, whether it is the open systems interconnection model, the Transmission Control Protocol and Internet Protocol Suite, firewall configuration, intrusion detection, or penetration testing with tools like Nmap, Wireshark, or Metasploit builds directly on this vocabulary. Take the time to make sure these definitions are clear and solid before moving forward.